Hey guys, how's it going? This is Siri and I'm back with another PyTorch video for you guys. So today in this video we're going to be talking about tensor storage and what goes on behind the scenes when we create different tensors. So how are tensors stored? Well, they're located in sequential chunks of memory, and these chunks, right? This is like a one-dimensional train of values. Okay, they're managed by torch.storage instances. Okay, so a torch.storage instance, like I said, is 1D. And, it obviously contains a number of a certain type. So int 64, float 32, whatever. It can be long and short, doubles, whatever, right? So it contains a certain type. And, tensors, which are just multi-dimensional arrays, right? They have, they have arrays within arrays. And you could have two tensors with completely the same values, but the dimensions and the way they are organized, although it's in the same order and although it's the same number, the brackets could be around a different number, so the dimensions would be different. In other words, you would index them differently. Okay, so a PyTorch tensor is just a view of a torch.storage instance. What does that mean? What are we even talking about? Well, okay, so let's import torch first. Okay, and things will get a little clearer. Okay, so we have a tensor. Let's call this tensor 1, and let's set it equal to a tensor. Okay, so I'm just making up values here. 6.7 maybe, and 8.2. Okay, I'm just making up values here. And maybe, actually, let's keep this 8.2 in the next one. Okay, 8.2, 3.9, and 5.12, 3, okay, we already did 3, maybe 2.5. Okay, so that's tensor 1. Tensor 2 is this basically the same tensor. It has the same values, they're in the same order, and like 9.8. Oh, what am I doing? Okay, 4.0, 6.7, 8.2, okay, 3.9, 5.12, and 2.5. Okay, so these are the same values, but the dimensions are different. And so what I'm proposing, or rather PyTorch is proposing, is that these tensors are just views. They're little glimpses of something called a torch.storage instance. And now that you have an instance, you must obviously have a module, right? So we have a storage module. And so, like I said, let's take a look at the storage. Okay, what this does here is that it returns to us what the storage of tensor 1 is. And so, okay. So you need to let PyTorch know that this is an array of 3 arrays. So we gotta put an outer array here. Okay. So tensor1.storage is, look here, 4.0, basically 6.7, basically 8.2, just 8.19, 3.9, 5.12 basically, and 2.5. Okay? So, let's take a look at the ID of the storage. Tensor1.storage. Print. Now let's print Tensor2.storage. Okay, we get the same one. 4.0, 6.69, 8.19, 3.9, 5.1, 2.5. That's because we have the same values, but they're just organized and rearranged in different ways. A storage, right, torch.storage instance is just a train. It's a train of values. And when you create a tensor, you're probably looking at a storage instance, except you're saying, hey, I'm going to break this storage instance up into, into 3 rows and 2 columns. And what you're saying with Tensor2 is, hey, let's take the same storage instance, except let's have another view, because that's what tensors are, right? Let's have another view. Instead of, breaking up the same train, the same 1D storage instance, instead of breaking that up like this, let's break it up like this instead, with 2 rows and 3 columns. And 2 rows just means, 2 arrays, and 3 columns just means 3 items, 3 elements in each. Okay, so that's what's going on here. We're looking at the same storage instance, but we are creating the tensor with the values broken up differently. And like I said, that means that you can index into the values differently. Okay? So let's take a look here. Print tensor, print ID of tensor2.storage. True. Okay. So, the fact that we were shown a different number doesn't really matter at this point, because, you see the 04 ending here? If you run it again, you're gonna get, different values literally, every time. So, yeah, 1 second. Let's test something out here. Tensor2.storage. Not sure if this is gonna work out, to be honest. Okay, it didn't. Whatever. 8.4. Okay, whatever. But we do see that the it's pointing to the same storage instance. Okay, so let's comment this out. Or actually, let's just delete it. Or yeah, whatever. Yeah, so they point to the same tensor, the same storage instance, which was the point that I was trying to make. And so when you run this, you get true. So it's the same glimpse. It's a different glimpse of the same storage instance. Okay. So yeah. Okay, great. So since the storage is allocated once for multiple tensors, right? So if you can have multiple tensors, maybe you could have broken up if you had like larger like tensors, you could have broken them up in various ways, although here we only did 2, and honestly you could have done another way, which was put all of them in one row or put all of them in one column. So yeah, those are different tensors, but they point to the same storage instance because it's the same string, the same train of values stored in memory that we're just taking snapshots of. And so actually we're taking the snapshot of the whole thing, but we're just breaking them up differently. Okay? So that's what's going on here. And so if you want to change the storage value, however, this is an important point to note. Okay, so for example, if you had t, let's just call that t, and we're going to create a tensor of values. Let's make it the same value, actually. Actually, let's just say that we're talking about tensor 1, okay? So let's copy this here. We don't need to, but just so that we can see it. And so let's say tensor1 dot storage. Actually, tensor storage. Okay, it's a variable name. Let's set it equal to the storage of tensor1. Okay, and we can clearly see that the values are the same, right? And we can clearly see that it's pointing to the same spot in memory. Okay. So, yeah, so this is the storage, tensor1 storage. And let's change the value of the storage. What's going to happen? So I'm going to say tensor1 storage. Okay, I'm going to say that the first value, and remember, when I'm talking about tensor storage, I'm not referring to this because this is, the shape is 3 by 2, okay? Tensors don't have dimensions. Storage instances don't have dimensions like that. It's just one dimension, okay? One string. So you can't use multiple indices to locate a value in the storage instance because the storage instance, once again, just to reiterate the point, it's just one long train or just long continuous or contiguous values that are, like next to each other. So you can think of it as like a rectangle and you break it up into little boxes and each of those boxes would represent a different value. And it doesn't have any other dimensions. It's not a rectangle. Did I say that it was? Okay, it's a rectangle, but it only has one line of cubes, okay? It's not like a matrix or anything like that. Okay, so let's set that equal to, okay, so tensor1's actual first value is 4.0. Let's set it equal to 2.0. Okay? Run it. And now, okay. So, what happened here? Well, you changed tensor1's storage. Okay? You set tensor1 dot storage's first value equal to 2.0. You changed the storage instance that tensor1 was associated with. Okay? That changed the entire tensor. Okay, do you notice that? Tensor2 should be the same as before. See, you didn't change tensor 2. So now when you print the IDs, they're not going to be the same anymore. It's going to print out false. Or it should print out false. Okay, it prints out true. Let's see tensor1.storage. 2.0. See tensor2.storage. 4.0. See ID of but you do notice that it changed the storage of tensor 1, right? Okay, great. So now you know that when you change the storage value, okay, let's write a comment here. When you change the storage value, you change the entire tensor, okay, because it's not pointing, or like it's not associated with the same storage instance anymore. Okay, great. So we mentioned that, you know, the only difference between these two tensors is the fact that they're different views of the same storage instance. And we also noted that that was the same thing as being, as like indexing the values differently. Because if you wanted to access 6.7 here, you would say, print tensor 1 0, because we're accessing the first row, and 1 because we're accessing the second element. Okay, and here, same thing here, print tensor 2, same thing, 0. Actually, it's the same. Maybe we should take a look at 8.2 instead, because that's like the border value here. So 1 and 0 and 0 and 2. Okay, so yeah, right? Great. So we're indexing them differently. So how does PyTorch even know how to index them if they're talking about the same storage instance? How do we know that tensor 0, 2 is the same as tensor 1, 1, 0? Right? What factors or what characteristics tell PyTorch how exactly these are organized? Those are 3 attributes, and they're called the size, the offset, and the stride. Okay, so what is this terminology and how does it help PyTorch know how you index into the tensors if they have the same storage instance? How can PyTorch tell the difference between the different views of the storage? Okay, so size is just how many elements across each dimension. How many elements are across each dimension? That's it. It needs to know because storage instances are just 1D. You need to know, hey, where's the break? Where does this break and go on to the next row or next column? Okay. So that's why it's important, right? How many elements are across? So this is basically like having, look here, I'm copying this, and it's basically like having them next to each other. We could put commas between them, but okay, yeah, let's do that because it's hard to see. Yeah, so how does PyTorch even know? Hey, this is where the next row starts. This is where the next column starts. This is where you need to go. This is the first element. Maybe the first element starts off here, right? And you go 2.5, then 2.0, then 6.69, right? Maybe you're starting at the end and you're going forward, right? So all these three attributes help PyTorch with that information. Okay, what's offset? Offset is the index, like I said, in the storage that corresponds to the first element in the tensor. Okay, or first value in the tensor. Okay, what's stride? Stride is the number of elements in the storage that need to be skipped over, that you skip over to get to the next element in the row or column. Okay, so that's how it knows, hey, this is where the next element is, this is where the next element of the row is, the next element of the column is, or if you had higher dimensions, right, you need a value for each, or you need the number of elements to skip over for each dimension to get to the new, the first element of the next dimension, if that makes sense. So it's going to be a tuple, so it's going to be the skipping value for each dimension. Okay, so it's going to be a tuple. And same with size, right? How many elements are across, or how many elements are, right? So let's take a look. Let's say, tensor 1 dot storage offset. Okay, let's print it. 0. Why? Why is it 0? The first element of tensor 1 dot storage is 2.0. So what if it was like, what if it was the other way? So where did we redefine? Well, we changed the storage value, right? Remember? So let's talk about tensor 2 instead to make things easier. Tensor 2 dot storage offset is also 0 because 4.0. But what if we said this was, let's create tensor 3 is equal to torch.tensor. Let's say 8.2 comma 3.9 comma 5.12 and 2.5, 4.0, 6.7. Okay, it's basically the same thing except we're shifting over. If you want, you can pause the video and see, right? We just shifted things over a bit. Now we're starting with 8.2. Okay, let's run this. And let's take a look at tensor 3.storage. Okay, so now it's starting with 8.9. 8.19. So now okay, there must be different decimal values because, like, you know, like if you're starting off, if you have the same storage instance, and if you're starting off with 3.9, you're definitely gonna get 0, 1, 2, and 3. So whatever, but you get the idea, right? Like, storage offset is the index in the storage that corresponds to the first element. So when you print out the storage, the first element that you get, no, not the first element that you get in the storage. The first element that's in the tensor, you look for that value in the storage and you see, hey, what index is this at? And that's the value that you return. Okay, stride is, you know, the number of elements in the storage that you skip over to get the next element. So let's take a look at tensor 2.stride. Tensor 2.storage, stride. Okay, is this stride? Okay. 3.1, and that makes sense, right? Like when you look at tensor 2, you know, 3, well, the first number is always the row number, and the second number is always the column number. So 3 is the first number, so you go over 1, 2, 3 to get to the next row, and then 1 over to get to the next column in the storage instance. So you go 4 and then go skip 3 values. You get to 3.9, okay, to get to the next row, and then you just have to skip over 1 in the storage instance, in this 1D storage instance. That's like the directions, like, translated over to the storage instance. Okay, so yep. And the relationship between tensors and its storage instance makes, like, you know, these operations a whole ton easier, because when you have to create a new tensor with the same storage, you don't have to waste time actually creating or, like, allocating new space for that tensor, because they share the same storage instance. So it's just another view of the same storage instance. You don't need to create some new values, which, you know, only waste your computational resources and your time. So yeah, so what this also means is that, like, if you change any of these, like the size, the offset, the stride, you get a new tensor, right? That's basically it. The only difference between tensor 1 and tensor 2, before we change the storage value, right, is that they have different values for each of these 3 attributes. Okay, and so what this also means is that if you change, like, the subtensor, you're gonna have an effect on the original tensor. So what does that mean? Well, if we have T, and, you know, I'm kind of sick of creating new. Okay, let's just say tensor T2 is equal to tensor 1, and it's going to be like the first array, or the second array, sorry. The second array, right? Index 1. So that's a subtensor, right? That's like a tensor within a tensor. So, I mean, it's an array within an array, but if you set it equal to a new variable, then T2 is a tensor now, right? So let's say T2, 0, is equal to some value that is not equal to tensor 1, 1, 0. So what do you get? So tensor 1, 1, 0 is... Okay, wait, let's print out tensor to actually know what tensor 1 is. So tensor 1 is that. Okay, so tensor T2 is 8.2, 3.9. So, and then the first value of that is 8.2. Let's change it to 9.2. Okay? So now let's print out T2. We get 9.2, 3.9. So changing the subtensor had an effect on the original tensor because, you know, you're also referring to the same storage instance here when you take a subset of that storage instance. And so you don't need like you don't need to allocate new space, which is why you get the same value here. Okay? If you wanted to change that, if you didn't want to modify the original one, then what you can do is that you can say, let's say T4 is equal to, or maybe let's just say T2. T2 is equal to tensor 1 of like 1 dot clone. Okay, and let's say T2 is equal to T2 of 0, which we recently set to 9.2. Let's say that that value is instead 10.2. Okay, so now we print T2. And let's print tensor 1. Okay, so 9.2 still stays the same here, and 10.2 is now the first value of T2. So that's the way it works. That's the way clone works. So there's probably one last thing I'm going to talk about. Or actually, you know, let's save that for another video. Let's talk about transposing like matrices in another video. That's built off of this like storage idea. Because we're running late already. Okay. So I hope you learned something new. I hope you learned that, you know, if you create tensors with the same storage train you could think of, it's going to save a lot of computational resources and your time. And so now I know. So now I hope you know like how things work behind the scenes. And when you see a tensor with the same values, you don't just say, hey, that's like a completely new tensor that's completely unrelated. Know that they are related with, but they just have different sizes, offsets, and strides. Okay? Thank you so much. I hope you liked my video. And yeah, I'll see you all in my next video.